Hello, students. How are you? I hope you are quite well. Your study is going very smoothly. Today, we are going to start the aldehyde and ketone. This is lecture number 5, method of preparations by reductions. Means through reductions, we understand here how to prepare the aldehydes. Okay? Or through reductions, how to prepare the ketone. Students, once you understand the whole concept, please like, share, and subscribe the channels. Here, I am going to tell you, I am going to discuss with you why each and every either the reagent or catalyst, what is the purpose of the reagent or what is the purpose of the catalyst, how these things will involve in the reactions. So whenever you read the NCERT, so that you can understand perfectly. Let's start, students. First, I write here, this is the Rosenmund reductions. See, student, Rosenmund reductions is what? Basically, it is a hydrogenations reactions. It is a hydrogenations reactions which is in the presence of H2PD barium sulfate, right? So we take this reagent H2PD and barium sulfate. Sometimes we take the quinoline also. So quinoline, barium sulfate act as a, or sometimes we take the quinoline. Students, the quinoline is what? See, this is the structure of quinoline. Okay, this is the quinoline structure which act as a poison substance. See that even the barium sulfate also act as a poison. See that, students, how it involved in the reactions. See that, students, alkynes converted into alkenes. It clearly shows that it is a partial reductions. It is a partial reduction process. Okay. Now see that same things we will take here. Acyl chloride. Acyl chloride is also reduces into the aldehydes. Okay. Now, what is the use of barium sulfate? Students, see that barium sulfate, which is the BaSO4. Barium sulfate reduces the activity of the palladium, students. That reduces the activity of palladium. Okay, that reduces the activity of palladium due to its low surface area. So that what happens when it decreases the reducing power of the palladium in order to prevent the over reductions of the acid. I would like to write here. So, so that what happens? So that it decreases the reducing power of palladium. Okay, in order to prevent the over reductions of the acid. Correct? This is the logic. So I hope you understood what is the use of barium sulfate. Now we talk about acyl chloride. How acyl chloride will react with the H2 in the presence of palladium and barium sulfate. See, students, acyl chloride, when you take the palladium mixed with a poison. Okay, that palladium mixed with the poison in order to prevent further hydrogenation. Correct? Mixed with poison in order to prevent further hydrogenations. So that what things will happen? RCOCl, when you take that palladium, right? Palladium insert here between the carbon and chlorine, and that things will happen palladium and chlorine, and you have taken the H. So one H will come here, and one H will bring the HCl. So that RC double bond OH will form along with the palladium and HCl. So I hope you understood how the palladium will work and how the HCl will remove. Correct? Students, now we talk about the second reducing agent, that is the DIBAL-H. See, students, DIBAL-H and lithium aluminum hydride, both are reducing agent. Student, DIBAL-H is a less reactive, means more selective. So DIBAL-H is what? Less reactive than La. Right? La means lithium aluminum hydride. Okay. Now see that students, see the structure of DIBAL-H. Here is that I write the here. Okay, aluminums here, aluminums, and here is that again. This is the aluminum. So this is the isobutyl. 1, 2, 3, 1, 2, 3, and this is the 1, 2, 3, right? So it will be 1, 2, 3, but whole is the butyl like that. Okay, isobutyl. So DIBAL-H, diisobutyl aluminum hydride. This is the diisobutyl aluminum hydride. Okay. So through this DIBAL-H, what happened? Actually, why DIBAL-H is less reactive strength? Because DIBAL-H is so much bulky. With the bulky nature of DIBAL-H, is very less reactive. So and the more selective. Hence, you can say that the ester like that substances, if you have ester through the DIBAL-H converted into aldehydes, and similarly, if you have a cyanide compounds that also converted into the aldehydes, right? Okay. Now you understand that how it is selective, which is more reactive. See through the one example here. CH, we have a CH and C double bond O, OC2H5, right? When you take a student lithium aluminum hydride, in the short form we write here the THF, and of course we have to take the water. And on the other hand, we take here DIBAL-H at the very low temperature, that is a minus 78 degrees Celsius. So through the DIBAL-H, double bond will not be disturbed, so that what things will happen? PH, CH, double bond CH, CHO. Simply aldehyde you can get that. But through the lithium aluminum hydride, you will get that not only this compound will convert into aldehyde, but also double bond will be converted into the simply alkanes like that. CH, 2CH, 2CHO will form. Okay. So I hope you understood the how the lithium aluminum hydride and how DIBAL-H will be reacting in the reactions. Now, student, one thing I would like to tell you, the DIBAL-H reacts slowly with the electrons poor compound. DIBAL-H reacts slowly with electron poor compounds. Okay, right? Electron poor compound means see, this substance is very less amount of electrons. This is electron poor compound. On the other hand, ester is electron rich compound because lone pair is there. Similarly, nitrile is also electron rich compound because lone pair is there. So this is the electron rich compound. On the other hand, this type of compound is electrons poor compound, right? So, and of course, the DIBAL-H is more reactive with the electron rich compound. It is a more reactive. With what? With electron rich compound. Okay. Now see here. Understand to the example the how DIBAL-H react with the ester. This is the mechanisms. I hope you will understand here. R C double bond O OR I have taken. Along with that DIBAL-H, in the short form I write here ALH and IEU all two. This is the isobutyl. Okay. So as you know that aluminum is electron deficient, which act as a Lewis acid. So here is that that things what will happen? Here is the so aluminum is electron deficient. That will here is lone pair that will attack on this aluminum, so that the RC double bond O OR and aluminum hydrogens I butyl all two, and these things will attack here, and as the result here positive charge will come. So hydrogen will shift here. This is intramolecular shifting here. So and then RC double bond O AL I Bu all 2 and this hydrogen will shift here so that the bond will click and the OR. When you do the hydrolysis, that OR will move from this center and then RC double bond OH plus ROH. You will get that, right? This is the whole concept of the DIBAL-H. This is the way the DIBAL-H will react with the substances. So in the NCERT, I hope you will understand where the givens along with the Stefan's reactions, that things you will understand. Okay. Similarly, students, when you have a nitrile, the same thing will happen along with the nitrile. When you take that ALHIBU, okay. So exactly similar manner, the similar way it will react like the ester. So RC triple bond and Al I Bu all 2 and the hydrogen will shift here. That bond will turn towards the nitrogen because nitrogens have given electron to the aluminum. So nitrogen contains positive charge. In that way, the bond will shift towards the nitrogens. So now when the hydrogen will shift, that will what things will happen when that will shift here with positive charge. So RCH double bond and AlIBu all 2. Okay. Now see here, students. When you take that water, that is the RCHO will form. Okay. So this is the logic of DIBAL-H. Okay. So aluminum atom accept an electron pair from the nitriles. Okay. Students, I hope these things you understood. Now we talk about the Stefan's reductions. Stefan's reduction. Students, see that through the Stefan's reduction, what happened? SnCl2 and HCl you have taken. That is called acetified because HCl we have taken. So it is called acetified stannous chloride. Student, that is the amine. It will form the amine hydrochloride. Amine. What amine means when you see that? What I am telling you, RC triple bond N. Okay. See that here is also you can see the difference between the lithium aluminum hydride we have taken and Sn plus HCl. This is the reduction agents. So through this way you can get the complete reductions. RCH2 NH2 you will get the complete reduction. This is called complete reductions. Okay. And through the SnCl2 and HCl and water you will get the RCHO, which is called partial reductions. Okay. Students, see the what things happen through this Stefan's reduction. Actually, SnCl2 react with the 2 moles of HCl, which will form the SnCl4 plus H2. That's fine. Plus 2 plus 4. Here is the oxidation happen, the 2 electrons. So simply I can write here Sn2 to Sn4 plus, that is the 2 electrons is liberated. Now this 2 electron, it will attack on the nitrile. You can see here the 2 electron you have, when the bond will shift towards the nitrogen, the 2 electron will come on the carbon. So the carbon will be reachable of electron, correct? And already you know the nitrogen already have taken the electrons. It also contains the negative. You have 2 hydrogens. One hydrogen will come here. One hydrogen will come here, and the form is RCH double bond NH. Now you take the hydrolysis, and through the hydrolysis RCHO plus ammonia you will get. Students, if you want to remember in a very short manner, you can simply write like that. Suppose I write here RC triple bond N. This is a trick. This is not a proper logic. What I am telling you. Suppose you have you want to form the product. It is just a trick. You have how many bonds you have? 3 bonds. 3 bonds means 3 moles of HOH I have taken. Now 3 moles of HOH means RCOH OH, and here is the 2 moles. You have to take the 2 moles, right? And 2 moles, so that the two bond will cleave, right? And if you want to take the 3 bonds will cleave, right? So what things happen if suppose 3 moles we have taken, the 3 OH will form. Students, when the 3 OH we have taken, the water will lose here. OH and H will lose here. And so that what happened? RC double bond O, OH will form. But if you want to take here the 2 moles, students, see that this trick I am telling you, it is not a proper concept. So when you have nitrogens in 2 moles of HOH you have taken, then what happened? RC, OH, right? And NH, and the 2 moles of hydrogen, then the NH2 will form. So and then when we heat supply, that form the RCH. But I would advise you to go with that logic simply. Here is the proper way. Okay, so this is the proper way, and then you can understand. Okay, so I hope you understood the whole concept, students. Thank you. Have a nice day. Take care of yourself.